Hey everyone, my name is TJ Johnson, and I am presenting my research report on cybersecurity regarding Amazon Web Services, VPC, and more. So as an introduction to Amazon VPC, Amazon Web Services is the most popular and widely used cloud computing platform available today. They offer a multitude of services to users. Amazon holds vast amounts of data in their servers, and security is obviously very important to them. So continuing on the introduction to Amazon VPC, security is fundamentally driven by their VPC network environment, and it allows users to launch safe and secure cloud-based applications. It also lets users define a logically isolated virtual networking environment. That's what happens when you're working within the VPC. And users can then launch applications into their defined virtual environment. And it gives them security because it launches on a private cloud. And it also retains all of the capabilities that working on the public cloud computing provider offers, meaning what Amazon offers. So my findings, a basic overview of Amazon VPC. It stands for Virtual Private Cloud. Its main function is controlling the network fabrics that a user's EC2 servers run on, and resources. By default, a user's EC2 instances uses Amazon's default network, but VPC lets the user provision a logically isolated section of the AWS cloud, where the user can launch AWS resources into a virtual network defined by the user instead of Amazon. This means that the user can customize the virtual networking environment their EC2 instances run on, and it is extremely customizable. So continuing on my findings, in a basic overview of VPC, users can define networking features such as their IP address range. They can create subnets. They can configure their own route table if they're feeling really bold. They can define network gateways, and they can also set IPs in either IPv4 or IPv6 format, and it will translate for them. And it allows users to do their own network mapping, which is how their network is connected physically. So the benefits of using Amazon VPC, so you can actually very easily set up a VPC instance. It's really fast to do. It takes like 10 minutes. And it is a simple utility with a very efficient function, meaning security in your networking environment for potentially sensitive data that you're storing in the buckets or EC2 instances. It's secure as a dev environment, and it is also very customizable. You can do a lot of stuff with setting up your VPC. So moving on to the cloud computing architecture. Amazon Web Services is isolated logically, the VPC is isolated logically from other virtual networks in the AWS cloud. What this means is you're not operating on the same network that other users are using in the public space. And once launched, the user can launch other AWS applications in EC2 instances into the VPC. So once it's set up, you're in the environment, then you can start to put your own applications into there in your own framework, kind of in your own world. You can specify IP addresses ranges for the VPC. You can add subnets. You can associate security groups, and you can also configure route tables. So you can do a lot when you're actually setting up the VPC. You can add multiple layers of security using security groups and network access control lists. We'll get into those later. And there are a few basic types of configuration. So continuing on with the cloud computing architecture, when a user connects to AWS, they connect to all instances on a default range of IPs from the 10.0.0.0/8 network. Amazon automates this. So if you just want to use AWS, you just want to, you just want to put some data in an S3 bucket, you don't have to go to this length. All users are on the same public network unless otherwise specified. Security groups exist to protect users from everyone else and give privacy, meaning if I'm on the same public network that everyone else is, I'm going to have security groups which will protect me and protect my data that's on Amazon's server. Amazon Web Services is actually approved by the Pentagon as being secure, so their security is pretty advanced. When setting up Amazon VPC, there are multiple setup options, which I will now get into. So the first option in VPC is to go public only. So what this does is it's essentially very close to the default, but it lets you define a private subnet that then has public internet access. So you get that private subnet and then you go on their public internet. The second option is to set public and private subnets. What this means is you're going to be doing your own network mapping. So you're going to be really getting into it. The next option is defining a private and hardware VPN. So this is going to let a user build their own VPN to the cloud, essentially completely isolated from Amazon's environment. Like, you're still using Amazon Web Services, right? But you're not on their network. You're not using their cloud. You're connecting your own VPN, which connects to the cloud. And then lastly, public and hardware VPN allows you to use their own hardware VPN. So you're essentially connecting to Amazon's web servers publicly using their hardware. Like, you can use your own hardware. So if I have a server, or if I have another device, I can use that to connect and make my own VPN to Amazon. So moving on to the network architecture. So there are a range of IPv4 addresses which must be associated with each VPC that the user creates. The range must be in the CIDR format. So an example of that would be 10.0.0/16, just as an example. And the address acts as the primary CIDR block for the VPC. And what CIDR stands for is classless interdomain routing. It's essentially a method for allocating IP addresses and the routing for the IPs. So after they associate the range of IPv4 addresses, the user can then add and remove any subnets that they would like. A subnet is a line that basically divides a larger network into a smaller and more efficient subnetwork. And if you do choose to add and remove subnets, you actually override the default one that Amazon gives you. So they still give you one, but then you override it because you make your own network map. Users may also assign IPv6 CIDR blocks for their VPCs and any subnets in their VPC if they so choose. So if you don't want to use IPv4, you can use IPv6 anyways. It'll translate when it goes through the gateway, and you can also set that up. So there are, interestingly, at least I found this very interesting, there are 5 addresses that are reserved for Amazon specifically. So 10.0.0.0 is for their network address. The 0.1 address is reserved for AWS for the VPC router. Their 0.2 is reserved for the DNS server. The 0.3 is reserved by Amazon just for future use if they ever needed it. And the last address in the range, the 255, is reserved for network broadcast. So you can't use that one as well. So you can't use any of those four, but any others you can use. So continuing on the network architecture, it is recommended by Amazon for users to create differing subnets for resources that need to be online and those that operate offline. Basically what that means is you're splitting your environment kind of in half, right? Because you're gonna have part of your internet be public facing and it's going to be online, and you don't want that to mix with data that's usually going to be offline, right? Because you don't want that data to be out there in the internet if it doesn't have to. So then you make another one, a private subnet for the data that is on the offline side. And then you create a NAT in the middle for them to communicate. But if the user does not know what their destination is, they can just label it as 0.0.0.0/0 for IPv4 or /0 for IPv6. This can be used for the public subnets route that directs internet traffic to the gateway. What that means, if you have a public facing one and it wants to communicate with the private facing one, you're going to throw an internet gateway in the middle of that, which is basically like a NAT, and then it has certain addresses that are let through, so not everyone can access it. Only within your instance the addresses can access it. So continuing on the network architecture, to enable internet communication, the user must define a public IVP4 address. This is known as the elastic IP address, and the static address that is associated with the AWS account, it creates it. So your AWS account is going to create it. Since within the subnet it is only aware of the private IP address that is defined, a one-to-one NAT is also required, and this is done by the internet gateway. That's essentially what I was talking about earlier with the public facing part of your VPC needing to communicate with the private facing that's going to be offline, and that's why Amazon recommends having the two separated. So that one-to-one NAT in the middle is going to facilitate that. This translates the outgoing traffic to the internet to public IPv4, and the elastic address specifically. And a route table for all allowed routes of incoming and outgoing traffic must be defined. So basically what that route table is doing is it's just saying, hey, these addresses can get through, I'm going to translate them, or these addresses can't get through, not going to let them through. And that's huge. Hey everyone, my video cut out, so continuing on with the presentation, we are going to go to present. Where are you, sir? There we are. All right. Oh. Just gonna shimmy on over. Okay, so looking at a few examples of AWS VPC architecture. So for the first one, this is not able to connect to the internet, and for each instance that a user launches using a non-default subnet, it gives them a private IPv4 address, but it does not have a public one. The user must define a public IP for the VPC to connect to the internet. This means that the instances shown above can communicate with each other but cannot access the internet. This is because they lack an elastic address. And this elastic address is crucial to actually be able to connect to the internet, because right in this gateway right here, you're being locked because you don't have an IPv4. So you can communicate like here, but here to go to here isn't happening. So moving on, example 2. So this one is able to connect to the internet, thankfully, because it does have an elastic IP address. The graphic above shows that the architecture for a VPC is able to connect to the internet. It's enabled because there is an elastic IP, like I said, and the route table defines how the network traffic is received, the route table being here. And the traffic is allowed in and out of the VPC. Within this VPC are IP addresses, subnets, and the EC2 instances. So that's everything in here. Looking at the third example, the graphic above shows that it is possible for a VPC to connect to the internet using a network address translation NAT device to translate the IPv4. This NAT converts IPv4 private to public IPs, so it can then go to the internet. The NAT device even has an elastic IP address that is connected to the internet through an internet gateway. The private subnet is able to communicate with the internet through the NAT device. This IPv4 address translation works both ways, meaning you can go in, but you can also go out. So it can go back from public to private if you wanted to go back in. Looking at a fourth example, this one shows that a VPC is able to connect to the internet. Internet access is enabled in the graphic because there is an elastic IP address. The route table defines how the network traffic is received and what traffic is allowed in and out. Within the VPC are IP, subnets, and EC2s. For the fifth one, this one is showing a site-to-site connection, which is another way for a VPC to connect. So basically this is two VPN tunnels that are placed between a virtual private gateway on the AWS side. So this is like a tunnel. They go to the router and it communicates with the customer gateway. And they go back and forth and they get through the internet that way. The customer's gateway is then located on their data center, and a customer gateway device is a physical device on their end, like a server or something, that they use as one side of the VPN connection. The last one shows something very interesting. It is the private link architecture, which is provided by Amazon, and it can create a VPC endpoint that creates an elastic network interface. This IP address filters traffic coming to the user's service and EC2 instances, which is very helpful for security purposes, and it's made very easy by Amazon. So you're actually just using this, going through private link, and then going right to AWS. Instead of setting it up yourself, they just kind of do it for you, which is nice. For the implementation of Amazon VPC, it's extremely simple. What you do is log into the Amazon VPC console, you navigate to your VPCs, you mark down the name and ID of the VPC that you create in that interface, and then you choose options, add subnets, change IPs, whatever you want to do, filter, which not content, but IPs can go in and out. And then from there you launch your resources and instances into the VPC, and you're going to want to change the creative VPC in the configure instance details page. And then you add the subnet and add a tag, and then from there, lastly, you assign an elastic IP address to the created instance, and then you go to the Amazon VPC console and choose elastic IP, and then you allocate a new address. So some of the uses for Amazon VPC are confidentiality of data. We got it. Companies and users can access their resources and store critical data in EC2 buckets, or S3 buckets and EC2 instances, without worry of other instances accessing their stored data, because your VPC is going to filter what IPs can connect and what can't, and that's huge. You're going to get reliability, and you're also going to get security. Security measures such as filtering, security groups, and network access control list means ton of options. So what the security group and the network access control list do is they basically filter the flow of traffic to the instance. So again, that's very crucial for security because you don't want other people's IPs coming in your instance. So it's just going to filter it. And then in conclusion, Amazon VPC is a fantastic option that is given to users who want to go the extra step to protect their privacy and ensure that their data is protected. Amazon holds an incredible amount of data in their servers, and it is important to users that they protect it. And this is what makes Amazon VPC so incredibly useful. And then following this, I have multiple sources. And that's it. Thank you guys so much for listening, and I hope you guys learn more about Amazon VPC. Thank you.